Alright, this is number 10 of homework 3. A 80-gram, 34-centimeter long rod hangs vertically on a frictionless axle passing through its center. A 15-gram ball of clay travels horizontally at 2.1 meters per second and sticks to the bottom of the rod. So here we see it stick. To what maximum angle, measured from the vertical, does the rod rotate? So first we have a drawing of what's happening here, but before we go into the problem, we're going to go over some learning objectives. So the first one is relating the moment of inertia to how far the rod will move. So just kind of thinking about what equations we're going to be using is going to be super important. In this case, we're going to be using the conservation of energy, using potential energy equaling kinetic energy in order to find the angle at which the total system will travel after the collision. Speaking of collisions, another learning objective is relating inelastic collisions to angular movement in this case. So a tricky part of that is just kind of understanding how to use the concepts of collision in this situation and thinking about how the rod and the ball go from two separate objects to one object and using the equations that we'll go through very soon in order to find the answer. So let's just take a look at the visual representation of the problem. We have our rod here, our ball of clay here, and this is what it looks like after it sticks. So we are trying to find the angle right there. So we'll see that we can come up with an equation for height in this case. So height would be the length minus the length of cosine theta. Theta is the angle that we're looking for. If we isolate L, then we can see that H will be equal to L times 1 minus cosine theta. And it's important to note that the moment of inertia of the rod is... Actually, we don't even use moment of inertia, so scratch that. But that's kind of how I start every problem, is just writing out what I would know about a situation or could potentially find useful, so that's why that was there. I just forgot to delete it. But first we're going to be using the equation that we just found for height and plugging it into what we know about potential energy and kinetic energy. So PE equals KE equals MGH equals 1/2 mv squared. Masses will cancel out, which leaves us with velocity being the square root of 2gh. And it's important to note here that the velocity is the velocity of this system after the collision. So because that's when the kinetic energy would come in terms of the rod. So what we will see is that we can plug H that we just found into this H right here. So that would be the equation for velocity. And remember, in inelastic collisions, we have an equation where that states that the final velocity is equal to the mass of the first object over the total mass times the initial velocity. So we know that the initial velocity of the bullet is 2.1, or not the bullet, wrong problem, of the ball is 2.1 meters per second. We know that mass 1 is 0.08 kilograms, and the total mass is here. The final velocity is the velocity that we just solved for up here. And so what we'll get is this giant equation where the only variable that we don't know is theta. So we'll plug in 9.8 for g, 0.34 meters for the length, and we'll see that theta is 57.99. So again, let's just zoom out of this problem. We'll see that a lot of the main foundation of this problem is trying to find and relate different equations with each other. So we see that we have related height and the length of the rod to each other, which we'll use to plug into our equation of potential and kinetic energy, which relates to the conservation of energy of the system, relating it to the inelastic collision, where we can plug in the V that we just found, in order to find the final answer, which is theta. So make sure to keep track of all your equations and your variables, and hopefully you'll get the right answer, which is pretty much how I do all my physics problems. So thanks for listening. Have a great rest of your day.